Okay, guys, so we're going to be doing part 2. So if you haven't watched the molar mass video tutorial, the one before this one, please do so before viewing this video. Okay, so in this video, we're going to cover conversions of grams to moles. And this is of the same substance. We're going to talk about different substances later, but for today, this is just for the same substance. So I'm going to give you some steps to go by, just like when we did dimensional analysis. A conversion involves a t-chart, a conversion factor, and then doing the math that follows. So step 1 is to always set up a t-chart. Right, and those look like this. Step 2 is to place the given, which is given to you in the problem, in the first top box. That's this one right there. Step 3 is to put the same unit diagonally down to cancel it. Step 4, put desired, or the one that you want, the desired unit above. So you know where that's going to go. So we're going to then use a conversion factor. And the conversion factor, when going from moles to grams or from grams to moles, is that 1 mole equals the molar mass. If you didn't watch that video, that's the number from the periodic table, the mass numbers, in grams. Okay, so we're relating moles to grams by molar mass. Let's do an example problem where we're setting it up so you can see what I'm looking for here. So let's do an example. Let's say that we have 25 grams of potassium chloride. So we'll start off simple, potassium chloride. So my given, what's given to me in the problem, goes in the very first top box. If my unit is in grams, then grams comes below, diagonally down, right, so that they cancel. And what I want are moles, because we're doing gram to mole conversions. Then I need to figure out what numbers go in this conversion. So I need to use a conversion factor. 1 goes in front of mole. So where I have moles, I need to put a 1. The molar mass goes in front of grams. So I'm going to have to calculate the molar mass. K weighs 39 on the periodic table, and chlorine weighs 35.45. Because it's in the middle, right, it's not close enough not to round, so we need to round that one. We don't need to round that one. 39 plus 35.45 gives me a molar mass of 74.45. So that goes in my molar mass area. Then remember, every T-chart works the same. We multiply across and divide by what's on the bottom. So 25 times 1 divided by 74.45. So obviously 25 times 1, I can just leave that as 25. Then I'm going to divide that by 74.45. That's going to give me 0.336. We'll just round that up. Moles of KCl. It's really important from now on that all answers have a number, a unit, and a substance. We really want to get in this habit so that later on in stoichiometry we don't get overwhelmed with how many numbers there are and what substance we're talking about. So all answers need to have a number, a unit, and a substance. All right, let's do another example. Let's say we have 2.49 grams of calcium hydroxide, and I want to know how many moles is that. So again, I'm going to go back to my steps. Step 1, set up the T-chart. Step 2, place the given in the first top box, right there. So 2.49 grams goes right there. Put the same unit diagonally down to cancel. So if this is grams, diagonally down means that grams go here. And then those cancel. Put the desired unit above it. So I want moles. What I want goes on top. Then I use a conversion factor. 1 mole equals molar mass. So 1 mole equals the molar mass of calcium hydroxide. Calcium weighs 40, oxygen weighs 16, but distributive property, right, only on the inside of the parentheses, not calcium. But we distribute this 2 onto oxygen. That gives us 32. And then hydrogen weighs 1, but again, I distribute, times 2 is 2. So that gives me 34 plus 40 gives me 74 as my mass. Then in my calculator, take 2.49 times 1, but I don't really need to type that part. And this is on the bottom, so we hit divide by 74. That gives me an answer of 0.0336. So because this was about a tenth less, this is about a tenth less moles of calcium hydroxide. Okay? But what if we wanted to go backwards? So I'm going to get some more space and move my paper. What if I wanted to convert something that was already in moles to grams? So let's do that example. What if I need to convert 0.45 moles of copper 2 sulfate, and I need to know how many grams that is? I'm going to use the same steps that I used on the previous page. If you need to flip back, you can do so. So step 1 is to set up the T-chart. Step 2 is to put the given in the first box. This time my given is in moles, okay? And that matters because the unit that I start with always goes catty corner down so that it will cancel. My desired unit is now in grams, so now grams comes above. My conversion factor is still the same for moles to grams. 1 mole, so the 1 goes on the bottom this time because it follows its unit. 1 mole equals the molar mass of copper 2 sulfate. So copper weighs 50 No, it doesn't. That's cobalt. It weighs 63.5. Sulfur weighs 32 and oxygen weighs 16, but I have 4 of them, so I have to remember to multiply by 4. 63.5 plus 32 plus 16 times 4 gives me a mass of 159.5. So 159.5 is my molar mass. That's equal to 1 mole. That's why they're in the same box. This box right here, this fraction. And then remember how every problem works. We multiply across and divide by the bottom. So 0.45 times 159.5 divided by 1. Now, if I don't really need to type in the divided by 1, because we should know that anything divided by 1 is itself. So when I type in 0.45 times 159.5, and that equals 71.775 grams of copper sulfate. Okay, let's do one more example of moles to grams before you move on to your worksheet. So if I have 5.68 moles of, I'm going to do a word problem this time, of nitrogen gas, how many grams is that? Okay, so again, I set up my T-chart. My given goes in the first box. If I start with moles, moles has to come below so that they cancel. Grams goes above. Then 1 mole equals the molar mass. Nitrogen is genuine, it's diatomic. You cannot forget what we learned last unit. So because nitrogen's diatomic, I have to multiply its mass by 2 to get 28. So then, in my handy dandy calculator, 5.68 times 28, you can type in the divided by 1 if you need to, but understand that the answer is just going to be 159 grams of N2. Thank you for listening.